So go pretty quickly. So we have two other triangle congruence theorems that we talk about. First one is angle side angle, and then we'll talk about angle angle side. So basically, angle side angle says that if two angles in the included side. So now we're going. Remember how we keep talking about that angle has to be between the sides for side angle side? Now we're talking the side has to be between the angles for this one. So if it's congruent in one triangle to the same sides, corresponding sides in the other triangle, they're going to be congruent, right? So I have angle, side, angle, then angle, side, angle, right? That side has to be between the two angles. Write yourself this little note. All right. So if I were to name these things as congruent, so triangle ABC is congruent, what order would I have to go in on the second one? D, E, F, right? Make sure you go in the same order. So there's angle, side, angle. It's going to be the same type of things we've been doing. Now you just have a couple more theorems in your pocket to use. Okay. Angle, angle, side. This is the last one that we'll talk about as far as works for any triangle. So this says if two angles in the non-included side. So this is important. It's the one that's not, it's not in between the sides. So, so if those are congruent to the two angles in the corresponding side, this is really important. It has to be in the same position. Those are congruent. So the key here is that you have the two angles, right? If you notice, the congruent side is across from the angle with two marks in it. Okay, I need you to pay attention. So I have to look over here and I have to make sure that the side that's congruent is across from the same angle. So that's why those two things would be congruent by this. We'll have the same congruent statement. All right, 3 examples, and then we're done. You have plenty of time to work. So, just want to know what theorem could I use to prove these triangles congruent. So, if I look at this first one, what do I know? So how many pairs of angles do I know are congruent? What, somebody just 2, right? And I have how many pairs of sides are congruent? 1. So my 2 options to use are angle side angle or angle angle side, right? So do you notice how before we could decide which one we were using because we went based on the side, what we knew? Here, both of these have 2 angles and a side, right? In the theorem. So I have to check and see if I go with my angle side angle and angle side angle, is the side in between the 2 angles or is it not, right? So here I ask, is this side and this side in between the 2 congruent angles? Alex says yes. Do you agree, Trevor?
Of course. How come you didn't ask me? Why is there 2 lines on the left on that one, but not on the left?
I wouldn't say that doesn't mean anything.
It's like, she's
So like, you're talking like this and this?
Yeah,
like, why is one doubled up instead of not on the other?
Okay, so
the 2 double ones are congruent to each other and the single ones congruent to each other.
yeah, so
So I didn't see her congruent to each other.
yep. So it's just think about this one as this triangle has been kind of flipped. So it's like reflected.
I thought they have to like, they're supposed to actually.
Okay. I want to explore that for just a second. So Scott just had a good question, right? The one with 2 lines is not in the same spot over here, right? That's okay. All that matters to me is that I have a set of congruent angles, so F and C are congruent, right? And then comes my congruent side, and then comes my other congruent angle. As long as they go in the same order, it doesn't matter if it looks backwards, that's fine. So this one, because the side is included, you can say angle, side, angle. So the second one, if I look at that, again, I know 2 angles, and I know a side. So I don't really have any way to look to here, but the thing important to notice is the side in between the 2 angles? So is the side that's congruent in between the 2 angles? No, right? So that means the only thing I can possibly use is this angle, angle, side. So I need to check, is the side that's congruent across from the same angle in each, across from the corresponding angle in each triangle? So if I look here, it's across from the right angle. If I look here, it's across from the right angle. So that's good, and I can use that, and I can say angle, angle, side. So if I look at this, this is one where they kind of give you stuff. So I want to check to make sure things are labeled like they're supposed to be. So this says that angle BAC is congruent to angle DAC. So is that there, right? Remember, BAC is going to be this angle here. DAC, that angle. So I have that marked. It also says that AC is perpendicular, right? That little thing means perpendicular. So that's labeled, right? If I look here, AC is perpendicular to that.
No.
So
Like tweak it because the thing is shaking.
what is one of the things that we're always looking for to make sure everything's labeled? 2 things we talked about making sure you look for in these triangles.
Talking about to add to it, basically.
Yeah, like what would we add to the diagram if we...
The lines, like, separate the 2 triangles or congruent, like,
We're talking this line?
yeah.
Yeah, right. I want to look for shared sides. So I know that's congruent. Here's another thing you can kind of look for. When things are perpendicular, right? Since this is perpendicular to that line, I know this angle is 90. What about this angle? 90, right? So I want to kind of draw that in too. So now I look, I still have my angles, my 2 angles in my side. So why angle, side, angle?
You hate us.
Because it's between the 2 angles, right? This side is in between the 2 angles. So I can say this is congruent by angle, side, angle.